Hey guys, it's Simon and welcome back to another video from me about a game that I made many years ago. It was one of my first games that I completed entirely and which I also uploaded then to Google Play Store that you could play it. And back then it was written in Java. So the name of it is Mystic Garden. You simply control a hero and it's a small puzzle-like game. So you have to collect all the different crystals. You wake up in a dark mythical garden, and once you have collected all the crystals and found your way through the garden, then you can activate a portal and get back to your lady. And I was motivated 1 year ago or 2 years ago to try to rewrite that in Kotlin, but I never had the time because I did some other projects back then. And finally this year I took my time for it and I have rewritten it now in Kotlin with the newest things and all the things that I have learned so far. And I used also the Fleks entity component system now instead of Ashley, and also the version 2.x. So this is a reference for that. And so what did I do with that? So first of all, there is now a better character control to the improved physical handling. I will show you that also in a moment. There's also a better lighting support with Box2d Light. There I have learned a lot over the years, and back then that was my first game where I used this framework and library, and I did certain things not in an ideal way and sometimes even, I would say, wrong. So that has improved a lot. I will also make a small tutorial about the Box2d lighting with our Mystic Woods tutorial series. There you will learn then how to add also the lighting effects to your own game. Then I have improved the user interface a little bit before. I will try to add those images then in the video with post-production magic so that you can see the difference. So before there was really like a lot of user interface and a very ugly one, I would say, at the bottom of the screen, which actually hid a lot of the gameplay itself. Now it's more minimalistic, but you see now the entire screen and the entire game all the time. I added a new item, so the boots are now also in this garden available, that the hero can walk a little bit faster. Did a lot of some animations with C2D and stuff like that. A new graphic for the chroma orbs, which which decrease the darkness of the garden a little bit over time. I've also improved the handling of the androids, or in general of the handling of the game, because before I added those 4 arrow buttons, which I think worked fine on the desktop application. I think you could still control with WASD, but on the phone, pressing those 4 buttons was really tedious and not very comfortable. It was not a nice user experience. So that I always wanted to change to a touchpad, which now I also did for the Android backend. As mentioned, I use the Fleks entity component system now, and there is also a browser support, which I will also show in this part. And before we go into the details of the different things that I want to talk about, be aware that I will add the chapters again below to the video so that you can jump to the important parts that you are interested in, and that you don't need to watch the entire video if you don't want to hear me talking about all the different things that I did there now the last couple of weeks. And I will also add the link to the video description below. So with this link, so that is now possible that you can play now this game actually in the browser thanks to TeaVM. So that's then available, and wow, it's a little bit loud. Let's decrease the volume, shut it down. Wow, that was super loud. And as you can see, so this is how it will look like then in the browser. And there, since I wasn't able to figure out how I can distinguish between the desktop browser and the mobile browser, I simply added the mobile controls here to the game. So I can distinguish between mobile and normal controls. So in the normal desktop application, you don't have the touchpad and this button, because there you have just a WASD movement, which also still works in the browser. But on the phone, you don't have a keyboard usually. So there you can then move around with this nice little touchpad. And that's it. So first of all, to give you a little bit of an example, what I did now with Fleks 2.0. So I tried to use the most modern approach for me personally, how I would implement the game with ECS using the Fleks library. And there, as mentioned, I used the version 2, so I think 2.2 or what is the 2.3 actually. And I also used a lot of data classes and the destructuring functionality of Kotlin. So for example, let's go to the boundary component, for example. There we have a data class with an XY value, a width and a height, and also the layer in which an entity should be rendered. So should it be backend background? Should it be default or foreground? It would actually support an arbitrary amount of layers. And yeah, with the destructuring, which I showed in a moment, there you can get, in my opinion, a very nice syntax. So for example, let's go to the animation system as an example. And there you can see that first of all, we no longer need all these component mappers that we had to do with version 1.x of Fleks. So this is now automatically working, and also the syntax is slightly different. So what I now did, as you can see here already, I normally remove the component part of the class name of a component. So it's no longer called animation component or boundary component. It's just animation, boundary collision, whatever, because with that I can then write something like that. So from an entity, I want to get the animation, for example. So this feels very intuitive to me, and I liked it. And also with the destructuring, as you can see here, so when we write the brackets, then I can simply get out all the values that I need from the component, like in this case, the animation, speed, state time, and mode, and then work with that. In that special case, I also need to set an integer or a float, I think it is in this case. So that's why I also need to store the component here separately to modify the original state here. But yeah, with that, you can see you can write really short or very concise code, and I like it. So I personally prefer it over the 1.x version that I had, and I also prefer it a lot over the Ashley component system. So that one feels really good. However, there's also a little bit of a downside, and this is more Kotlin related, I would say. I think they want to add certain functionality in one of the upcoming versions, but at the moment with version, I think I used 1.8. Yeah, I used 1.8. There it's currently not available. So as an example, when we go into the render system, for example, where I also use destructuring. So for example, from the render component, I get the sprite. From the boundary component, I get X, Y, and the width. That one I think I could basically remove. And as you can see here, so if you need just one specific part of your data class, and with the destructuring, as it works at the moment in Kotlin, is that you cannot use named destructuring. So let's go to the render component. And there you see, for example, for the sprite, I added my own extension functions for component 1, 2, 3, 4, so that I get the X, Y, width, and height. And in case you only need the width, like I needed it in the render system here, for example, then you cannot just get out the width of the data class that way. It always has to be the exact order of the components that you have described here. So I always need to get X and Y. Even if I don't need it, I have to write it down and then just get the third component out of it, the width. So that's why here I didn't use it. So you can add the underscore, and then the width, which is in certain scenarios a little bit, yeah, not so nice, I would say. So it would be cool if Kotlin supports something like destructuring, I don't know, width, and I want to call that, for example, sprite width. I think this is the syntax, how it works in TypeScript, for example. Then you could shorten that down. Of course, in that special example, I could simply write a sprite width. That would be the same. To be honest, I most likely fiddled there a little bit around and needed more of these properties initially, and then at some point I just removed them. So that's why it's now looking like that. But yeah, this is more like, I would say, a Kotlin issue at the moment, that you cannot write that in a more shortened way, and also that you cannot destructure the data class with named properties. But again, from what I heard, I think they want to add that in one of the upcoming versions, so then things like that would become a little bit nicer. Also with Fleks 2.0, I was a little bit worried that the boilerplate stuff that you need to add for every component in order to work for it. So with this new component type that normally the companion object extends from it, so that we get this syntax sugar. I thought that this would be a little bit annoying. I also thought about maybe adding how do you call that? Is it a compiler plugin? Not sure, but something that automatically generates this boilerplate code for you. So I thought of something like an annotation, like component or Fleks component or whatever, and then it would, in the background, automatically create the the boilerplate code for you with the component type and so on. But in the end, I'm actually lucky or happy that I did not choose that path, because there are, as always, special exceptions. And for example, for the Box2d Light component, I needed, or the way I solved it, I added two different component types for the light. So one for the point light and one for the cone light. And I wanted to reuse the same component data structure, because it is actually the same. For me, I don't distinguish between a point light and a cone light. And since I don't have this magic happening with the compiler code generation plugin stuff, since I can modify the code the way I want it to be, so then it was not really a problem. So there I could then write something like that with this, and then it was simply working. So I like it. And also nowadays, since we have live templates, I think Visual Studio Code has it as well, but also, of course, in IntelliJ you have it. You could just add your own live template. For me here, for example, I set up Fleks C for a new Fleks component. Then I give it a name, I don't know, for example, health or life or whatever. And then, tada, I already have my component in here with all the boilerplate stuff. And then I just add something to it, I don't know, live points, which would be an integer. And that's it. So with the live components, it's really not an issue. You have to set that template up once, which is also pretty simple. So down under settings, you can search for a live template. So live templates. And then here, for example, under Kotlin, I added the Fleks component. And that's basically it. So it's a one-time setup where here the code looks like this. So this is how... can I move that a little bit up? Yes. So this is how I, for example, set up the live template code for me for the Fleks component. And that's it. So then it's really not an issue. So I don't need to type that part here all the time again and again. It gets automatically created for me. And I think that's totally fine. And yeah, worked out for me quite well. So the next thing that I have improved on was the Box2d lighting stuff. So there I will, as mentioned, I will make a tutorial soon for the Mystic Woods tutorial series that we have, because I think it's not that complicated to add some lighting to your game. So you just add this Box2d Light ray handler, I think it's called. Yeah, exactly. So that one here. And there in the original game, I will also try to show the images now in the post-production. In the original game, in the Java version, the lighting was a little bit too bright, in my opinion. So it did not look that good. And there was a solution to that. So you can simply use the diffuse light and set it to true. Then the light in the game itself is not that bright anymore. So let me quickly show you that. I just start up the game. So here, as you can see, you can still see the normal hero graphic. Just normally, it's not super bright, but in the Java version, that one was really, really super bright. So the hero was very, very white and lost a lot of its color. So that one was not that good. I think also when colors or lights were overlapping here a little bit, it did not look that good in the original version. Now it looks a lot better, I would say. Also, I don't know if I added that to the original game, but in this game I added a little bit of this, I call it the breathing effect, so that the light goes a little bit in and out there. So I also added those kind of things. And what was a little bit tricky for me to find out again was, first of all, how you can still see the objects when you are close to them, because before, when I went directly here to this tree, then everything was dark. I could not see behind that because, of course, there's a Box2d body here in the background, and there is a collision happening between the hero and the trees and the light itself. So here it would be a point light, and this point light of the hero would not go through obstacles. So I could not see the trees, which I did not like a lot, but there is a solution to that. So you can make your light shine through other obstacles a little bit, and you can do that with the set softness, I think it was called. Let me check quickly. Yeah, exactly. Set softness length. Unfortunately, there is not real documentation, so it's just set softness value for beams tips, which I have no idea what that means. But in the end, with the default value, not sure what the default value is. So the default value is 2.5. That one did not work out for me, so there I had a little bit of a problem. Let me quickly restart it so that you can see that what is the difference with that. So that when we change that to 2.5, or we simply comment it out, then you will see the difference there. Okay, so I turned off the softness now completely, and now you can see, so when I get close to an object, I don't see what it really is. So it really gets blocked here. So the tree is not available or not visible, although the light actually of the player would be a lot bigger, so I can see, like, for example, up there, but when I go to here, I don't see the obstacles anymore. So in some games, maybe you want that behavior, but in that specific game, I did not like that behavior. So the solution was there to set this softness length. And I didn't find that out myself, so I went to the Discord channel there, and there, I think, what was his name, Bad Entity or something, in the libgdx Discord channel, he helped me with that and told me that there's a method like that, and I just play around with it, and yeah, that worked. So that was one of the things to find out, and also the render system itself. So with the lighting, improved a lot over the Java version. So right now I just have a separate light system there, and there you simply call this ray handler set combined matrix, and then this update and render, and just call it after the normal render system, and that's already it. Then you're good to go. I, of course, did then some special things here. So as I mentioned, this breathing effect of the light, this is also part of this light system. So in this update light method there, I simply update the maximum distance of the light. So it's this distance that you can set here. And with the cone light, it's also this cone degree, so that the cone also goes up and down a little bit. That one I added myself. But in the end, for Box2d Light, it's pretty straightforward. And also with the rendering, as mentioned, it's not that complicated anymore. Let me quickly show you the previous render system. So there I tried to analyze it and understand what I did back then, because the goal of all that stuff was to simply re-implement the original game, but use the more modern Kotlin approaches that I have learned over the year. And I still looked, of course, into the old systems that I had. So like, for example, this game render system back then, I called it like that. And there was really a lot of stuff happening. So I had here some scissor stack stuff, because I wanted to optimize the rendering, that things which are outside of the camera, that they don't get rendered. But I learned that later on, from what I know, this is entirely not needed at all, because OpenGL already does that for me. So what I have as a viewport boundary, so in which viewport I'm rendering, everything that is outside of that is already automatically clipped. So it does not matter if I make a draw call there or not. That one gets already optimized from what I know. And also there was some special thing then with the user interface, because it was overlapping the bottom part of the game. So when there was a resize happening, which I also handled in the system, I did some special calculations to move the viewport in a special way and do something with light, scissor heat, and whatever. And it was really, really not that intuitive what I did there. Also, I couldn't remember all the things that I tried to solve back then. And now with the new version, I think it's way more straightforward and easy to understand how it works, and also how to modify it. Then coming back to the Kotlin branch, there were, of course, always some tricky things as well. So I developed a little a zone system. What I mean with that, so what is a zone for me? So as you see now in the game, when we are moving from a certain area of the garden to another area of the garden, then there was like a little camera transition, so that like in the old Zelda games. Let me open it up. So let me quickly collect that crystal that destroys the trees down there. And now when I move to a different area, as you can see, the camera is here then slowly moving upwards and downwards, so to the new area boundaries. And it feels a little bit like the old Zelda-like games. I think I don't know which game had that first implemented, but I just know it from Zelda. And there were some tricky things, actually, which I did not have in the original Java game version, because the Java game simply loaded the entire map, all the objects, and that was it. And I always thought that, of course, for a small game like that works, but I always want to think a little bit into the future, how you could improve that. If you have a bigger map, I don't know, with how many different zones, of course, you don't want to load everything at once and also iterate through all the different entities all the time. So, for example, calculate all these particle systems here of the portal or of the crystals or of the fire that I can also show you then in a moment. And yeah, so that's why I improved it in the Kotlin version. And there I actually always create and destroy all the entities of a different zone. So now I'm in, let's say, this eggs zone where you can find the eggs. And when you enter it, then it actually spawns all the objects. And when you leave this area, then it actually destroys all the objects again. So the crystals, then these different obstacles here, the torch, for example, the particle systems, all of that gets removed. And that was actually a little bit tricky, because you don't want to immediately remove all the things, because when you go to another area, I will show you that when I picked up the egg. So when we go back, you don't, as a player, want to see that the crystal immediately disappears. You actually don't want to see that at all as a player, because you don't care how things are implemented in the background. So I needed to add some sort of a delay, so a delayed removal of entities. That was not the super tricky part, but still I had to consider it. And also I need a way to also remember, so what kind of objects are still inside a zone and which ones are already removed. So for example, when you collect already this crystal, the next time you enter the zone, you don't want this crystal to appear again. So that's why I needed a way to remember all of that. So I used the libgdx preferences for that and saved that I simply saved the tiled entity IDs of a zone, which are still available, and only the IDs that I found in the preferences, they will be loaded in a zone, and all the other IDs, they will not be loaded. So that was one of the tricky parts that I found out during the development. Then also user interface. You know me, I hate user interfaces. And of course, I always have these nice ideas, so what I want to achieve. So for example, what I wanted to do when you pick up an item like these eggs, I wanted that it's part of a table, so of a pop-up dialog, which says, hey, you found the eggs and now you can cut trees. And then I wanted to move that image of the table out somewhere. So initially I had it at the bottom, but now it's at the top, so that this image then flies to the top and the player somehow sees, hey, he collected something. I solved it now slightly differently, so get impressed by this amazing animation. So ta-da, we found now the eggs. We cannot move for a couple of seconds. We also get some sort of description, and then the eggs, bam, flies up there, and now we have it collected. And now with that, we can, for example, cut the trees. Also, we can collect up here this orb, for example, which lightens up the garden a little bit. And yeah, the problem was with this animation from flying to the bottom to the top. First of all, I couldn't figure out how I can add an image to a table and then just freely move it to a different position. So it seems like when something is part of a Z2D table, it has its own position calculations and everything, and for me it was impossible to override it. Then I thought, okay, that's not so difficult. What we can do, I can simply calculate the position of the information table, put the image in there with some offset calculation, and then animates the image to go up there. But also that was not possible for me. So I also left some comments in the code where at some point I just stopped trying to achieve what I wanted to achieve, because it was basically impossible for me to figure out how to work with Scene2D. And in the end, I achieved what you have just seen before. And in the next project, for sure, I want to try out this Flexbox implementation for libgdx. There's a new library which I think came out a couple of weeks ago. And someone sent me an email that he tried that out in his own project. It was, of course, as always, I think with user interfaces, not that straightforward and intuitive to work with, but he was able to, for example, implement a responsive user interface. And I hope that it's just a little bit more like the normal CSS part in HTML, and not this Scene2D own garbage stuff, which I almost never understand. So I can work with it. As you can see, I can achieve certain things, but sometimes when I want to achieve my own ideas, I have no idea what it's always doing in the background, and it's, sometimes behaving very weirdly. So here again, one more time, nice pop-up. I just noticed here there's a problem with the German translation. I need to fix that. Then the item appears slightly over the table and moves to the top, and now we have it available. And let me just show you something. You can read this comment to find out about my frustration, what I had with Scene2D, and this is just one of the examples. And then another tricky thing was actually to teleport the player. It was not tricky, but not that intuitive for me. Because what I had implemented, so there's a save and load system, and for example, when I click on continue, then you can see I'm immediately where I left off before. So the player is not in the original area, he's actually here. And with Box2d, there would be different things how you could achieve that. So just also as a background information, the player always spawns at the initial position for me. This is just how I implemented it. And when I load a save state, I need to like teleport him to the real position that he has. One way would be to just call the, I think, set transform or whatever it's called on the body and transform the body somewhere here. But there I read that it's not behaving properly from time to time and could cause strange issues then later on in the game development because you bypass the real physics and then some internals or some calculations of Box2d are not the way that you would expect them to be. And I had that in some other games as well, where I also did that approach where I just set the transform of the player and move him to a specific location. Sometimes he could not really jump that location because he got blocked by some bigger obstacles and then he just ended up in the wrong position. And sometimes some other strange things happened. I think that the movement at one point in one of my games was then also broken after some of these teleportations. And yeah, the way to go, which is then easy to implement and works then in the end, is simply you destroy the body of the player. So you destroy the original body and create a new body at the location where you want it to have. So that should be the safe solution to approach that and to fix that as well. And then you can implement like a normal teleportation. Just destroy the body and recreate it somewhere else. With Box2d, there's then also some tricky things because the light that goes out from the player, that one is attached to the player body actually and moves automatically with him. And there just one time during a test phase, I found out that the light then actually just remained at the original position of the player, and when I moved it, the light was still at the original position, so it did not move anymore with the player itself. And there I had to just add another small fix to attach the light once more to the body after it gets recreated, and that solved then the light issue for me as well. Then save and load system. There, to be honest, the solution that I implemented there was not really nice. Why is it not so nice? So first of all, I did not want to invest a lot of time into that. It was the final part that I implemented in the game, and it was already not that nice in the original version, the Java version. And the approach that I wanted to choose was actually that I simply dispatch an event. So I say, for example, save game event, and then the different systems and whatever things need to react to a save event in my game would react to that, and then write some things to the preferences like the player position, the game time that he used, the crystals that he had collected, the items that he found, and things like that. And I think that solution would be cool because then you can independently just implement a save system, and everything that needs to react on a save and load just does that internally, and you don't need to have one entire function which does all of it. So the entire saving and loading, which gets bloated over time, I guess, the more complex the saving and loading becomes in your game. And I wanted to split that up. The problem was that was actually not so easy to solve because of the way an entity component system works, and that some of the entities might not be available the first time when you load something, or actually certain things of your loading, like, I don't know, setting a player position or adding items to it, they will trigger certain things in your systems, but only once you loop through it. So only if you have one update step in between. And in the end, there were some timing issues with that in that specific game for me. Most likely, you could solve that when you think about that from the get-go and implement your systems in a better way, that also saving and loading is not a problem and that you don't get these timing issues. But in my case, it did not work out that well. I simply had a problem with some of the loading mechanisms. And in the end, I implemented in the same way like I did in the Java version. So there's a save game which simply does everything. So I get the player position, time, crystals, orbs, items, and the move speeds. Those are the important informations that I need for my game. And they get stored then in a preference file. And the same when I load then the game, this is also just one function. There I get all this information out of it. If anything is missing, I throw an error because then something did not work properly in the save mechanism. And then I simply manually, one by one, do the different things that I need to do. So for example, in the map system, I need to destroy all the entities and objects which are currently available. Then I need to reset the zone, so the camera zone and the active zone of the zone system. Then I need to reset the game time, the light, and all these things. So all of that is happening in that method. And at the moment, this is a really simple game. And as you can already see, there's quite a few things that I already need to do. And you can imagine that this is most likely not the best approach to solve that than for bigger games. So there, I think it's better. And for me, also still, I like the idea that I just trigger an event, and then whatever system and whatever logic or area in my code needs to react to that and do something with saving or loading should do that independently. But with that, I really, at least with the entity component system approach, you need to be a little bit careful with the different timings. And I did not want to invest that much time to figure out or to solve the timing issues that I had. And I just went to the original approach, which works, which is also totally fine just to complete this little side project. But again, don't follow that, what I did there. Then what I also found super helpful actually was a debug render system. I think that was the first time that I ever implemented that because as always, if you follow my other tutorials, I like to split up the logic parts a little bit between the real game logic, then the user interface part, and the renderings part. So I don't tightly couple them together, so they are a little bit independent. And that's why, for example, as we have seen before, with an entity, I have a boundary component, which has a position, width, and height. And this is then actually let's solve for all the logic parts, so with the moving and so on, or collision detection and so on. That would be the real values in the background, which are used for an entity. Then there is, of course, a render component, which is simply then a sprite, which again has an XY coordinate and also a width and a height. And that one contains then also the graphics, so where something should get rendered. Then there is also a physics component, which has this physics body. The body, again, in the physics world, has again his own position, width, and height. So there are already 3 different components which are just attached to one single entity, and they should be aligned together. And normally, I just have, I think, the Box2d debug renderer, and that is sometimes not sufficient because I also wanted to see what are the real values of my boundary component and also what are the real position of my sprite in the end. Because when it comes to scaling, rotation, maybe some offset with the graphic, I wanted to see how all of that behaves and to understand how I would need to adapt the render logic. And there, this debug render system came really in handy, where I simply use a shape renderer. And then, for example, for the boundary in the color teal, I draw the boundary rectangle of the entity and also the sprite rectangle with a white color. And that really helped during the development of the render system. Let me quickly check. I think I just added there a flag. So debug render, I think when I set it to true, then it would render already this debug stuff. Let me quickly check that and show it to you. Yeah, exactly. So that one was really helping me a lot. So the big boundary here, I think that is actually the sprite of the player. And as you can see here already, that would be not that intuitive if I don't have the boundaries shown here with the debug renderer, because you would think it's only the graphic itself, which is the sprite, but that's not true because it's a sprite sheet. So there are a lot of different animations of this hero model in one image, and in between the different frames, there's always some white space, let's say, or some blank space in there. And that's why the real sprite actually is bigger than what you see in-game. Then we also have the Box2d body, which in this case is just a little circle where you can see, maybe you see that in the video, it's a little bit jumping around because we have then, of course, this interpolation approach again available, that we have a smooth rendering. And then we have this teal box here, which is then the real boundary of our entity. And you can see already the sprite gets correctly centered horizontally, and with the vertically it just gets aligned with the bottom of the player entity. Also the collision objects itself that you see, where are they getting rendered and so on, because that one I usually mess up initially, that they don't get created at the correct position or they are too small or whatever. And with this debug render system, that really helped a lot during that stage to easily find out the problems that I had there and to fix them properly. So this is an advice that I would give to you. Just add a little debug render system to your game. As you see, it's not a lot of code. It's very, very simple, I would say. And with that helps a lot with finding out the rendering issues that you might have in your game. Okay, and finally, what I find really cool is the TeaVM backend for libgdx. So I think this is something really brand new. So this is not available for a long time. Also, the documentation there is not that great yet, I would say. But with the GDX lift-off setup, you can already create the TeaVM backup, which is then simply converting your Kotlin bytecode into most likely some JavaScript bytecode or whatever it does, so that you can run your libgdx Kotlin game in the browser. With Java, you would use WebGL from what I know. So it's the JWT Google Web Toolkit stuff, but with Kotlin that does not work. And with Kotlin we now have the solution of TeaVM, which works there, but that has one little downside. So it does not work with everything. So if you use a lot of reflection or some special reflection stuff, not all of the reflection functions are supported. And for example, in our game, so the Mystic Woods tutorial, where we use GDX AI and with a special annotation, I think to get in some properties of the behavior tree into the code, that one, for example, is currently not supported, and that's why the TeaVM backend would not work with the Mystic Woods game. But it works perfectly fine with the Mystic Garden game here. So there we have the Fleks entity component system, we have Box2d, we have Box2d Light, I use preferences, Scene2d, so I actually use a lot also sound and audio and everything, and that one is working. So I would say a great chunk is already working, but some special things, especially with reflection things, that don't work at the moment with TeaVM. And in the end, you simply have another launcher. So there are two different ones that GDX Liftoff is creating. You have this TeaVM builder where you say what should be the title in the browser, then the width and the height of the canvas where your game gets rendered to, and then you have the and also the main class, of course, so which should get started, and then you have the launcher itself where you then start this TeaVM application with your game and the configuration from above. And there, don't get confused. So I got confused by that. There is another width and height in this separate configuration. But in my opinion, it should not be an integer, because according to this documentation, it seems like that it only supports the value 0 and -1. I initially had there the normal values of the canvas, so I used that width and height values over there. And on the mobile browsers on my phone, it did then look very, very weird. So I changed that then to 0, 0, and then it's working just fine in the browser, as we have seen in the initial video. And the way I solved that is that I used here GitHub pages. So in your repository, under settings, somewhere, pages. Exactly. And there you can select a branch. So for me, I created a new branch, which is called GitHub Pages. I think this is also the default name, and maybe that gets created automatically. That one I cannot tell you. And once you have that available, then you can, you also need to, in the actions of your repository, you need to enable that you have read and write permissions. Let me scroll down there. So this read and write permissions need to be then also enabled for your GitHub workflows. And what I did then is simply under code, let's switch to the Kotlin branch. So GitHub workflows, GitHub pages publish. There is a little workflow which then basically builds the game with. So first of all, it sets up the JDK. Then it builds the game with the TeaVM backend Gradle task, and then it publishes the game to the GitHub pages branch. And what it does, so it reacts to pushes on to the Kotlin branch. So when I change something in the Kotlin branch, then this action gets triggered. And also with workflow dispatch, I can also manually trigger that action. So when I go to actions, publish to GitHub pages, for example, then I can run this workflow here manually from the Kotlin branch. So this is the second part here, so this workflow dispatch. Then the action also needs write access. So this is this permission contents write, that it can write the new files to the GitHub Pages branch. Then here you define the job, so it runs on Ubuntu latest. And then we have the different steps. So what is this action doing? And as mentioned, so first of all, it checks out the repository. Then it set up the Java JDK to version 11, which is used in this project. Then it runs a Gradle task, which is called TeaVM build. So this is building the TeaVM backend, which basically compiles the core project and also does then some TeaVM specific stuff like copying the assets to a specific folder and things like that, which is then necessary to work with the game in the browser. And finally, there is then this GitHub Pages deploy action, which then deploys the folder TeaVM build this web app, which gets created in the TeaVM project and copies it to the GitHub Pages branch. And it looks like this. So when we go to the GitHub Pages branch, there you see you have then this webin folder, an assets folder, TeaVM folder, this index.html, and that's it. So it does not have the source code and so on. It really just has the code to run the game in the browser. And you also get then this link. So in this case, Quillraven, GitHub IO, and Mystic Garden, which is the name of the project. And when you click on that, then it simply loads it in the browser. And one thing, so did I build it here already? Yeah, so there you can see it. So under TeaVM project, there's this build folder, and then the distribution, web app, and there you have this assets, TeaVM, webinf, index.html, and all of that you can see here also on the GitHub Pages branch. So basically, that folder that you see here gets deployed to that specific branch here, and it simply gets then hosted on GitHub itself, and I like that a lot. That one is really, really cool. Okay, and that's it. I think a lot of talking, just a little bit of chit-chatting about that project that I did now, and that's it. So this week and upcoming weeks, I try to make some new parts for the Mystic Woods tutorial series, as mentioned about the Box2d Light stuff, then also about changing between different maps. And also someone mentioned that he wanted to know or learn a little bit more how I would test the different game parts or unit testing in a libgdx game, how I would go about that. And I hope that I find time for all of these three things, but should be hopefully possible. And then we hear each other in those parts again. Other than that, have a nice rest of your day and hear each other in the next video. Bye bye.